Hello again. Recently, you have seen the HyperX Alloy Origins blow up in the OSU community, with many top players saying how it's the cheater keyboard. The biggest selling point for the Alloy Origins is that it has the HyperX red switches instead of your regular Cherry MX reds. The main difference between the two is both a higher actuation point of 1.8mm instead of 2, and a total travel distance of 3.8mm. The actuation force and the bottoming out force being 45 grams and 60 grams respectively being the same. Other than that, the Alloy Origins is exactly the same as any other TKL you can find on the market. This isn't the first alternative switch that boasts a higher actuation point. If you recall, Logitech did something similar with their tactile Romer G switches, which had a 1.5mm actuation point. This switch also saw some popularity in Nosu for a while as top players like Ryuke, Dummy, and Fafarian all used the switch. Kale and Cherry also has their own speed switches, with the Kale speeds at 1.1mm and 1.2 for Cherry MX speeds. What do these numbers mean in games though? Well, from a statistics sense, less distance traveled means that physically speaking it takes less effort and movement to actuate the switch, meaning better OSU performance, right? Does a higher actuation point equal to better OSU performance? Is there a too high of an actuation point? All of these questions bring us to the keyboard that I actually intend to talk about, which is the Razer Huntsman TE, which has an optical switch that has a staggering 1mm actuation point, the highest of the pack. I bought this last year, so I've already unboxed it, but since this is YouTube, I've taken the liberty to recreate the unboxing experience as it is surely an integral part of the consumer experience. Inside the box you will find, surprisingly, the keyboard, a braided USB Type-C cable, some meaningless reading material telling you to consume more Razer products, and also how to plug in a keyboard to your computer. And, most importantly, stickers to let you inform other people of your consumer practices. Well then, I finally get to the point, the keyboard. While we are on the subject of superficial garbage, let's discuss the aesthetics first. The keyboard is surprisingly subtle for Razer. A simple, standard 10 keyless layout. No more of that dumb Razer bottom row, meaning that you can swap out the keycaps, as I've done so here. A little Razer logo above the arrow keys in that Razer Gamer minimalist font. A little bit excessive, but it's subtle enough. The font used on the keycaps is very non-gamery, which admittedly looks quite good. However, the keyboard, unfortunately, in my opinion, has a floating switch design, meaning that the upper housing of the switches are visible. Some people like this. Some people, like myself, don't. Turning the keyboard over, there's a print repeating the Razer motto of "For gamers, by gamers," again and again, and some information about the keyboard. And the 4 rubber feet that gives in total 3 angles of angle adjustment, meaning that it stays on my table without sliding around. And lastly, a USB Type-C port, which is very nice to see on a gaming keyboard. Unlike other companies who find it acceptable to sell you micro USB devices in the year of 2021, the detachable cable also lets you use other cables that you like, including a Type-C to Type-C cable that I've used here. Construction-wise, this keyboard is quite well built, quite light at 739 grams. The metal plate at the top gives it almost no deflex. Overall, it feels decently solid compared to other mainstream keyboards, but nowhere close to custom territory, as I am certain that I can kill someone with my Tofu 65, but not the Huntsman. As for the experience of using the keyboard, it's complicated. Let's start off with the switches used on this thing, which are optical switches made by Bloody, and then rebranded into Razer switches. With an actuation point of 1mm, actuation force of 40 grams, and a bottoming out force of about 65 grams, optical switches means that the switch uses light to actuate the switch, unlike your regular Cherry MX switches, which uses physical contact between 2 pieces of metal. As you can see in the animation, the slider blocks the light until you press it down, and then the light shines through a hole in the slider, which is then picked up by the detector on the other side and then actuates. The switches are also compatible with regular keycaps, including the spacebar, backspace, enter, and so on, using their own design for stabilizer, which are these little Lego Technic connectors. Every switch also has its own stabilizer, which we will get into later. Razer will have you believe that this makes the switch faster and have no debouncing. I don't know what this means, since I'm not far enough into my engineering degree. But I can tell that this optical technology does have its benefits, As there are 0 moving parts within the switch, other than the slider, this means that the switch operations is incredibly smooth compared to MX Reds. These are much smoother, making the Reds feel like sandpaper. It almost gives the Huntsman the illusion of being looped when compared. But this does not make the typing experience on these enjoyable, leading me to the first criticism I have with this keyboard. The switches on this thing are so light that sometimes if you rest your fingers a little bit too hard on the switches, you will actuate them simply with the weight of your fingers. In combination with the fact that the actuation force on this is a mere 40 grams compared to 45 on the Cherry MX Red, making typos on these is incredibly easy. They are also so light that you don't really get to feel the smoothness of the switches since there's so little feedback. Razer really had a very interesting switch, but they had to ruin it by giving it extremely light springs and also an extremely high actuation point. Which, while we're on the subject of that, most optical switches on the market also have a variable actuation point, namely the Wooting keyboards and also the SteelSeries Apex Pro series. But the Huntsman TKL's actuation point cannot be changed. You are stuck with this 1mm on everything, gaming, typing, or anything else. You may think that actuating keys with the weight of your fingers is very unlikely to ever happen to you, but I assure you this is very common. There are more problems than just being borderline unusable for typing though. This thing is loud, and I mean loud. Despite being a linear switch, this keyboard somehow manages to be even louder than my Box J's, which is a clicky switch. Here's a sound test of the Huntsman. I feel like this has something to do with the keycaps, which are PBT. However, these are some awful PBT keycaps as they somehow shine after 6 months of daily use. I didn't know that PBT keycaps can even do that. It also has a rough texture to it. Personally, I don't mind, but this is something that you should be aware of. The alternative stabilizers used on this keyboard are also pretty bad. While it is compatible with normal keycaps, the stabilizers are really loud and also annoying. Lastly, the software, Synapse, I don't know, which I had to reinstall for this review, only to realize that I need to have a Razer account in order to change anything, meaning that I have to give them my information. However, there are indeed quite a few RGB settings if you're into that sort of thing, including a visualizer mode. Personally, I don't care much for RGB, but even I find that the RGB could be a little bit brighter, and that the RGB doesn't really light up all of the lettering, particularly on the Enter and Shift keys. Alright, time to actually get to the point, the big question. What about OSU? At first, I just wanted to talk about my personal experience using these switches, but I realized that this isn't very objective. Therefore, I have devised a benchmarking system to do the testing. Here's how it goes. I have in total 4 switch types: MX Reds, MX Blues, Box J's, and Razer Opticals. First, I warm up on OSU, then I'll go on to a streaming test site, and do 20 notes or key presses first, doing 10 runs with each switch, and then 50 and 100 5 times each, and lastly 250 notes 3 times each. All tests are done on the same day, doing the same session, and breaks are taken between ones to ensure that the tests are independent. And here are the numbers. For 20 notes, I was able to achieve an average of 370 BPM on all 4 switch types across all 40 tests. This short length shows that for bursts and short streams, differences with actuation points and also spring rate have no impact on raw speed. As for 50 notes, on MX Reds, Blues, and KO Box Js, I achieved very similar BPMs, hovering around 330 BPM. Differences were only between 1 to 2 BPM, therefore within the margin of error. However, interestingly, I achieved 343 BPM on the Razer opticals, over 10 BPM higher than the others. I'm not able to say with confidence why I was able to stream this much faster. This could be down to that these switches actually make a difference, or variance across runs being particularly skewed towards the opticals. On 100 notes, I was averaging 315 on reds, blues, and opticals. However, I was only able to do an average of 309 BPM on jades. This may infer two things. 1. I did not take long enough breaks between runs, or 2. The high spring rates did come into play since the jades has a peak of 65 grams on the downstroke. Lastly, for 250 notes, however, the difference is gone. Similar to the 20 note test, I was able to achieve an average of about 296 to 300 BPM, again within the margin of error. After these tests, it's clear that the switches have very little impact on actual speed and stamina. However, the feel between the switch to me did make a difference, and I find that it was particularly tiring to stream on jades, even if I wasn't actually any slower. So, to answer the question, does a higher actuation point matter? I think the answer is no, and now I have the data to support it. Again, it all comes down to the feel of the switches. I find it the most comfortable to stream on MX Reds, even if I'm not streaming any faster or slower on them. Sometimes this could be a difference. Placebo is a very powerful effect. For the case of the Alloy Origins, I personally don't own one, but from my research, I found that people say that the HyperX Reds were much smoother than regular Cherry MX Reds. Therefore, this really could be the reason why it's the cheater keyboard. The smoother key feel could make all the difference. As for the Huntsman, conclusion time. At $130, this is one of the few optical mechanical keyboards you can buy, but as time goes on, the number of competition increases. Now there are alternatives from Wooting, SteelSeries, and Corsair, and I'm sure more and more are coming. The biggest problem is that the Wooting and SteelSeries keyboards have variable actuation points, meaning that you're unstuck with an outrageously high actuation point. And they also can do analog inputs, which is something that the Razer cannot provide. Razer seems to have noticed this, as they just released the Huntsman V2 as I'm just finishing this script, which does support variable actuation points. This doesn't mean the alternatives are better though, only different. The Wooting 1 only goes up to 1.5mm, the Apex Pros go up to 0.4mm, but they cost almost $200. Corsair's K100 is full size but is $230, and it's also stuck at 1mm. There's also a Wooting 2 Hall effect that's coming out, which goes up to 0.1mm, but that costs $220. The question of whether or not you should buy a Razer Huntsman comes down to one question. Do you want an extremely light and smooth switch? If your answer is yes, then I recommend this keyboard. But if smoothness is all you want, either buy the cheater keyboard or, better, save yourself some money and loop your current switches. Alright, that's I forgot how many videos I've made, but this is another one. I hope you enjoyed this. I'm learning how to take B-rolls and also recording with a blanket over my head. This took a long time to make, so sorry for making you guys wait. My next video is probably going to be another OSU discussion.